Hi guys, last lesson we learned about permutations, where the permutation NPR is a number of arrangements possible for an ordered selection of R objects from a total of N objects. Today we're going to learn about combination. So this is when the order is not important. For example, when AB is the same as BA, the number of arrangements is called a combination. A combination describes an unordered selection of R objects from a total of N objects without replacement or repetition. So, for example, choosing a team of 2 out of 4. If we were to do this with permutations, we would do 4p2 equals 12. So we'd have our 12 options here. But when we do combinations, our double ups are not important. So that means that we have AB and BA, they are the same, so we cross out BA. We have AC, which is the same as CA, so we can cross out CA. We have AD, which is the same as DA, so we can cross out DA. We have BC, which is the same as CB, so we can cross out CB. We have BD, which is the same as DB, so we can cross out DB. And we have CD, which is the same as DC, so we can cross out DC. So as you can see here, when we use a combination, because order is not important, we only have 6 possible outcomes, and we use the notation 4C2, which equals 6. So the combination NCR is the number of ways of making unordered selections of R objects from a total of N objects. So we can see here that NCR equals NPR, which is just our permutation, over R factorial. So NCR equals N factorial over N minus R factorial times R factorial. This is also where NCR can also be written as big bracket N over R, close the bracket. Or it's not over R, it's just N on R. So to get a combination on the calculator, you hit Shift divided by button for a Casio. So if we were had 10 objects and we only wanted to pick 3, we'd go 10 Shift divided by 3 equals in order to get our combination. So it would look like this, 10C3 on our calculator. And when we do that, we get 120 as our answer. So I have a few examples to go through with you. So the first one is a bag contains 3 white and 2 black counters labelled W1, W2, W3 and B1, B2. If 2 counters are drawn out of the bag, in how many ways can this happen if order is not important? So because order is not important, what we say is that how many things do we have in our bag? So we have 5 counters. So we say N equals 5. Then we say how many are we picking or how many are we choosing? So we are choosing 2 counters to be drawn out of the bag. So we say R equals 2. So because of this, using our combination notation, we write 5C2, which is the same as 5 factorial over 5 minus 2 factorial times our 2 factorial. So this is the same as 5 factorial over 3 factorial times 2 factorial. So when you put this into your calculator like so 5 factorial over 3 factorial times 2 factorial, you get an answer of 10. So you can do it this way, or you can do it on your calculator where you would go 5C2 on your calculator by hitting Shift divide, and when you do that you also get 10. So that is on your calculator. For our second example, we have if 12 coins are tossed, find the number of ways of tossing tails. And we want to toss 7 tails. So what we do is, using our notation, we say how many coins do we have in total? So we have N equals our total number of coins, which is 12. and we are choosing 7. We want to have 7 tails. We're choosing to have 7 tails. So we say R equals 7. So in this case, we write in our notation 12C7, which is the same as our 12 factorial over 12 minus 7 factorial times 7 factorial, which equals 12 factorial over 5 factorial, 7 factorial. So when we put this into our calculator, like so, we get the answer of 792. If we were to just put 12C7 onto our calculator by hitting Shift divided by, we get the same answer of 792. So you don't always need to use this notation here. In our third example, we have a committee of 5 people is formed at random from a group of 15 friends. So what we want to do first is in how many different ways can the committee be formed. So the order is not important of the number of ways the committee can be formed. So we have that N equals the number of people that want to be on the committee, which is 15 students, and then R equals the number of people we can choose to be on the committee, which is 5. So we can write this as 15 choose 5. So when we put this onto our calculator, we will get an answer of 3003. We can also write 15 choose 5 in this notation of 15 on 5, all in brackets. For part B of 3, we have if the group consists of 9 senior and 6 junior students, in how many ways then can the committee be formed if it is to have 3 senior and 2 junior students in it? Well, first we need to work out how our senior students can be picked. So for senior, we have a total of 9 students. So that means that our N equals 9, but we can only choose to have 3 people on the committee. So that means seniors will equal 9 choose 3. Then for our junior students, we have 6 junior students that can be chosen that are on the that are in the group, but only R equals 2 junior students that can be chosen. So for junior students, we have 6 choose 2. So to work out the total number of arrangements, what we have to do is we have to multiply this together. So to multiply these together, we have arrangements, not just arrange. We have our senior students, which is 9 choose 3, multiplied by our junior students, which is 6 choose 2. So when we put our senior students of 9 choose 3 in our calculator, we get 84, and 6 choose 2, we get 15, which equals a total of 1,260 ways we can pick 3 senior and 2 junior students to be on our committee. For example 4, we have a team of 6 men and 5 women is chosen at random from a group of 10 men and 9 women. If Kay and Mark both hope to be chosen, that's meant to be hope, to be chosen in the team, find the probability that both will be chosen. So because one of the key words in this is find the probability. So we need to find first the number of possible teams before we can work out how many of them how many possible ways there will be for them to be chosen, and then the probability. So the number of possible teams is that we have our ways our men can be chosen and our ways our women can be chosen. So off to the side, our men can be chosen there's N equals 10 men and R equals 6. So it will be 10C6. And our women, there is 9. So N equals 9, but only 5 can be chosen. So it's R equals 5. So 9C5. So that equals, multiplying these two together, 10C6 multiplied by 9C5, which equals 210 times 126, which equals 26,460. So that's the possible amount of teams that can be chosen, but we want for both Kay and Mark to be chosen. So we need to work out how Mark can be chosen. So if Mark is chosen, then only 5 out of 9 men can also be chosen. So that equals 9C5. And if K is chosen, then only 4 out of 8 women can also be chosen. So that equals 8 choose 4. So for the number of combinations for both be chosen, so combinations for both Kay and Mark to be chosen. Forgot my H. Will be our Mark, so 9 choose 5, Mark was chosen, times if K was chosen, which would be 8C4. So when we multiply that together, it is 126 times 70. So it equals 8,820. So then to work out the probability of both being chosen, we put our combination of both K and Mark be chosen, which is 8,820, over the total possible teams, which is 26,460 to get, and when we do that, we put that in our calculator and we get the probability will be 1/3. Then we have the probability that neither K and Mark will be chosen. So for K and Mark not to be included, then 5 out of the other 8 women and 6 out of the other 8 men will be chosen. So for men, if they're not chosen, it will be out of 9. So that Mark has been taken off, so it will be out of 9. And that means that 6 other men will be chosen, so it'll be 9 choose 6. And for the women, if K is not chosen, it will be that there's 8 women left with 5 places available. So it will be 8 choose 5. So to find out if the number of combinations for this, we might just redo that, see. So the number of combinations for neither equals our 9 choose 6 times our 8 choose 5, which equals our 84 times 56, so that is 4,704. But we're finding the key word in the question is find the probability that neither will be chosen. So we have to go the probability calculator. So that will be our combinations of neither Kmart being chosen, which is 4,704, over our total number of combinations, which is 26,460, which when we put that into our calculator, we get 8/45. So that is how we calculate combinations. If you are following the Margaret Grove textbook or Maths in Focus for Mathematics Extension 1, you do exercise 305.